Hey guys, we're going to start the next section today. This is all about right triangles and proving right triangles are congruent to other right triangles. So first thing we need to know are the different parts of the right triangle. Um, this part here and here are going to be called the legs, different than what it would be for an isosceles triangle. The legs don't always have to be congruent. The side that is the longest side is called the hypotenuse. So no matter what, the hypotenuse is always the longest side, and it's always opposite of the right angle. So whatever the right angle is, go to the opposite, and that's the hypotenuse. And the sides that are touching the right angle are going to be called the legs. There is one. Okay, so there's one theorem we're going to be working with, and that is called the hypotenuse leg theorem. Hypotenuse leg theorem says if the hypotenuse and leg of one right triangle is congruent to the hypotenuse and leg from another right triangle, then the two triangles are congruent. So if we have triangle PQR and triangle XYZ, they're both right triangles. PR is congruent to XZ, and PQ is congruent to XY, then those two triangles are congruent. So here's what it would look like. We have PQ and XY congruent, PR and XZ congruent, so the two triangles are congruent. We have one leg, hypotenuse, hypotenuse, and then the angles would be congruent. Now we're going to go and try to do a proof of this. Okay, so I set up the problem right here. We are given that these two triangles are right triangles with with right angles being at Q and Y. PR and XZ are congruent, the hypotenuses are congruent, and the legs are congruent. We're supposed to figure out how to solve these two triangles. So the first thing we're going to need to do is you draw a line on YZ that extends out farther, and you're going to name some point on this line that is S. Now the thing is, SY has to be the same as QR. So SY has to be congruent to QR. So I'm going to mark 3 right here, and then I'll mark 3 right here, and then I'm going to make this like that. So my S should be over here now. So now we are definitely going to have this. So now we have SY and right angle and XY, so we can show that this triangle here is going to be congruent to this triangle here. So we can show that triangle PQR is going to be congruent to triangle SYX by SAS. So since those two triangles are congruent, we can also show that SX is going to be congruent to PR. And that's because of corresponding parts of congruent triangles are congruent. So we have that, and then we can also, so PR is going to now be congruent to XZ. PR is going to be congruent to XZ, and that's by the transitive property. We have PR is congruent to SX, XZ is congruent to XS, so XS and XZ are congruent. XZ and PR are congruent, PR and XS are congruent, so XS and XZ are congruent. Then from here, we can show that angle S and angle Z are congruent. So angle S and angle Z are congruent. I should say N. And that's because that these two have the same length, so the opposite angles would be the same. That's the isosceles triangle theorem. So now we have a side, an angle, and another angle. A side, an angle, and another angle. So we could show that this triangle SXY is congruent to XYZ by AAS. And then we're going to use the transitive property one more time. PQR is congruent to XYZ by the transitive property. So we use the transitive property a couple times here. First time with the drawing for PR to XZ, and then PR to XS, and then XS to XZ. And then we went from there, angle S and angle Z are congruent because we have the isosceles theorem. Isosceles triangle theorem says that if we have two sides that are congruent, the legs are congruent, the angles where those sides don't meet will be congruent. So then we have an angle, angle, and then the side. Angle, angle, and then the side, and the angles that are opposite of the side are the same. So we can show these two triangles are congruent. And then these two triangles, PQR and XYZ, would be congruent because of the transitive property. Alright, going into some basic things about right triangles. Okay, to use the hypotenuse leg theorem, HL theorem, we need to have three things. First one, we need right triangles. If you don't have right triangles, you can't use this, especially we need two right triangles. Next, we need to have the triangles have congruent hypothenuses. Both triangles have congruent hypotenuses. And the last one is there is one pair of congruent legs, and making sure that the legs are the same. So those are the main three things that we're going to need to show that we can use this type of theorem. Alright, we're going to go through one example problem. Okay, so the example problem here says that CD and EA are congruent. AD is the perpendicular bisector of CE, so we need to show that these two triangles are congruent. So we have our statement and reason. First thing we could say that AD is the perpendicular bisector of CE, and that's because it's given. Now from that given, we could show a couple of other different things. We could show that triangles CBD and triangle EBA are right triangles. And we can also say that CB, this length here and this length here, are congruent, and that is all from the definition of perpendicular bisectors. So from that one step, we showed that these two triangles are right, and this side and this side are congruent. It's important to know that when you are doing these proofs, they should follow some kind of order. So you said this fact that this is perpendicular bisector, then what does that tell you next? Next thing you could say is CD is congruent to EA, and that's given. So what I meant by that is if you wanted to say this one first, that's fine. If you said this one first, you're going to have to say this next. You can't say that CD is congruent to EA given, because you should have some kind of order and flow from this. Okay, so now we have the hypotenuses are congruent, the legs are congruent, and we have right triangles. So we could show that these two triangles are congruent by the HL theorem. Alright, that's going to be it for today. And we're going to do some different activities in class today.